So we were talking about enthalpy, and what is another term we can use to mean enthalpy? H, yes, but we can also talk about it, although we wouldn't define it this way, we can always also talk about it as the amount of potential energy. So if we have an exothermic reaction based on enthalpy, which reaction is favored, or sorry, which side is favored? Are the products favored or are the reactants favored? Now, what that means is, do we make more? Does nature want to make products or does nature want to make reactants? So is it true that nature wants to make the products in an exothermic reaction? Or is it true that nature wants to make reactants? Have a little chat about that with your neighbor. So where would nature rather be? Would nature rather be at reactants level or would nature rather be at products level? Products, okay? So the products are favored in an exothermic reaction, and that means when the forward, oh, for goodness sake, you silly pen. So when the forward reaction is an exothermic reaction that nature wants to make product, nature favors the product. That's how we phrase it, okay? Okay. So on our next page, in an endothermic reaction, or sorry, in an exothermic reaction, the products are favored because they are at the lowest potential energy. Another way of saying lowest potential energy is to say minimum enthalpy. Those two mean the same. And nature always wants to be on the side with minimum enthalpy. In other words, nature always favors the side with minimum enthalpy. What's another way we could say minimum enthalpy? Lowest potential energy. Okay, so nature always favors the side with the minimum enthalpy, lowest potential energy. Which side of the reaction is favored in an endothermic reaction? This is when the forward reaction is endothermic. Chat with your partner about that. See what you think. Who is favored? Reactants or products? Everybody. Yes. And what does it mean to be favored? It means you're going to make more of it because that's where nature wants to be. Okay, since the reactants have the lowest potential energy, in other words, the minimum enthalpy, lowest potential energy, then minimum enthalpy always favors the reactants when we have an endothermic reaction. And I've just written here, when I say endothermic, I mean the forward is endothermic. When I say exothermic, I mean the forward direction is exothermic. All right, I would like you guys to try these. Which side, products or reactants, does minimum enthalpy favor in each of the following? Please try those. And remember, if you have any difficulties, draw yourself the little graph. Okay, what do we got? A is reactants, yes. B is products. Don't worry, I'll go through and break these down in just a second. C is products. And D is reactants. All right, so over here, we have an endothermic reaction, which would look like this. So where does nature want to be? Nature wants to be at the lower potential energy, the minimum enthalpy. If we were to put these kilojoules into our reaction, where would they go? In the reactants or the products? Products. All right, and that makes that an exothermic reaction. So if we draw our little graph, it would look like this. And where does nature want to be? It wants to be in the products. And guess what? The next one is identical because our heat term is also in the products. And if delta H is positive, where do the kilojoules go? In the reactants. So if you want a very quick way to predict this, how can you predict it using the heat term? Nature, minimum enthalpy always favors the side with the heat term. Is good? Okay. We're going to get started on entropy. I don't think we're going to get that far, but there's a couple really good videos. There's from Mr. Kolger. that I'm going to have you watch this evening, okay? All right, minimum enthalpy always, oh, look at that, favors the side with the heat term. Minimum enthalpy always favors the exothermic direction. Okay, entropy. This is a terrible definition of entropy, but it's going to do for grade 12, okay? Entropy is the randomness of the system. Another way of saying that is it is the disorder of the system. The symbol is S. Why is it S for entropy? I think because there's a lot of E words like energy and enthalpy, and they needed something. So they're like, okay, we haven't used S yet. Let's use S. Change in entropy is, of course, delta S. And nature always tends towards more randomness, more disorder. In other words, maximum entropy. The movement towards maximum entropy is spontaneous. That means it's what nature wants to do naturally. Nature does not like moving towards orderliness. So that is a non-spontaneous process, which means that you need to put some work in to make it happen. Now, I could not find a picture of the same desk that was messy and clean. So I found a picture of a bedroom that was both messy and clean. But you can use my desk as an example, although you haven't been subjected to the worst of it this year because I share my classroom with another teacher. So sometimes I do have to clean it up every night before I go home. But when I wasn't sharing with another teacher, sometimes things would pile up. I mean, you can see even now, I mean, there's stuff all over. How did it get that way? It got that way spontaneously, just naturally. There is stuff all over my desk. That was spontaneous. Yes? How do we go? What do we have to do in order to make it look orderly and less random? We have to do some work. Unless you're Ms. Bellier, in which case she just naturally puts everything back. But, you know, she also doesn't like ice cream or peaches, so maybe she's just a little bit weird. Who doesn't like ice cream and peaches? Don't tell me if you don't. I'm sorry. I apologize if you don't like them. It's not actually weird, but yes, it is just a little bit, just a little tiny, teeny bit. Okay. All right, so that's what we've got. Oh, look at this. What have we got here? What type of matter is this here? This is a solid. This over here is a gas. Which one is more random? The gas, because you know what? Not only are the particles more separated, so they could be in all sorts of different locations, they're also busy moving in a whole bunch of different directions, yes? Now, a better definition of entropy actually has to do with degrees of freedom. And if you would like to hear about that later, you may come and talk to me about it, but I'm not going to teach it right now, okay? So the gas is more random, which means it has, does it have higher or lower entropy? Higher. Oops. Forgot the H. Higher entropy. And this guy over here has lower entropy. So what is happening to entropy as we go from left to right? Entropy is increasing or decreasing? Increasing. Therefore, what is the sign of delta S? Delta S is positive. Okay, because we went from low to high. So nature likes it when enthalpy decreases. That means when delta H is negative. And nature likes it when entropy increases. In other words, delta S is positive. Alrighty, your homework is online. Like I said, there's 3 videos for you to watch. They're about 5 minutes each. And then there's some questions, a little bit of reading and questions for you to do in the book.